Hello, so we are back, and this time we have a customer job. This is a nice gaming laptop. It's a Acer Predator Helios 300. So this is a nice one. Now I will not try to open this one. I will not try to plug it in, because the customer said he opened the laptop and on the motherboard there are some burn marks. Yeah. And before I seen the laptop, I told him, if the board layers are burned, I don't think I can fix it. But otherwise, we should be able to fix. Okay, so let's open and have a look inside. Okay, all screws are out. I think. Yeah, all are out. Let's open the laptop and have a look inside. Let's see how it's supposed to be open. Do we have more screws here under? No. This will be easy to be open. Should be easy. Yeah, looks like they are plastic clips. Okay. Yeah, we have one screw here. I forgot about this screw. So, do you see anything on the board? Like burn marks? I can't really see anything. Burn marks. Okay, let's take the board out, because I don't want to plug before I see exactly what burn marks are. Let's take the heatsink out. Like capacitor burn marks, like MOSFET burn marks, like a motherboard layers burn mark. Wow, this screw. Okay, the fans. Last one. Not sure, but oh, you know what? It's a burning smell here. We have the Wi-Fi's. So do you see any burn marks? I'm looking. MOSFETs looks good. MOSFETs looks good. What else? Okay, now I like how they use here a metal shield, and here is the video RAM memory. I can take the board out and have a look on the other side, but I want to see the burn marks. Let's go with the power supply, yeah? Let's keep the voltage down. Around 1 amp. And let's see our main power rail, yeah? Where we can find our main power rail. So those capacitors are not ceramic, but should be on the main power rail. And we have a short. Check on the power supply. 171, that's the limit, and the voltage 0.09. And I test on the plus of this capacitor. So the main power rail is shorted. Okay, good. Now let me take the thermal camera. You know, I feel bad. You know I feel bad. You know, I had the live stream today, just speaking about the coffee. I feel bad. I feel like I just left the people. I left them alone. I seen on the chat and the Sorin said, Sorin, yeah, but not everyone has a thermal camera. And that's right. And it make me feel bad. We should use like normal finger touch finding a fault. But it made me feel bad. I mean, indeed, I don't think I can go back and work without a thermal camera, which it's insane. I work alive without a thermal camera. And I have that feeling I can't go back and work without a thermal camera. But I'm pretty sure we can use our finger. Well, let's use the thermal camera this time, just because this laptop is kind of expensive. And if we have a shorted MOSFET, I don't want to push a lot of current onto the GPU or CPU. Okay, so we have a thermal camera. Let's go with the voltage on the same spot. Yeah, here. Now let's see what we can spot. Anything getting hot, warm. What do you see? Do you see anything? Okay, that's the GPU. Okay, so the GPU is getting hot. You can see. Now let's check the MOSFETs. Where are the MOSFETs? Here. Any MOSFET which looks weird? No. So we can clearly see, look, check there the GPU, yeah? No, that's the CPU. What the? That's the CPU. And that's the GPU. 1 second. The GPU is not getting hot. Sorry, that's the GPU. And here is the CPU. The CPU, it is getting hot. And the MOSFET is the first one. Now, 1 second. Let me be sure. Okay, that's quite bad. The first one or the second one? The first MOSFET or the second one? You see, that's I'm trying to explain you, working with less current, because otherwise I will not feel with the finger a shorted MOSFET. Just working with less current, we can work safer. I mean, even with 5 amps, I don't think I can burn the processor, but you know, if we can do it with less current, it's better. Good. Now I'll get the hot air, I will remove, I don't know if it's the first or the second one. Let's see if we can spot which one it is. I don't think I can. Maybe you can spot. So one of these two is burned. The first or the second? Which one? I don't know. Okay, let's use some flux. Here, here, and here. And let's remove the first one. I will use max temperature because I want to be quick. Hopefully the processor is still good, but I don't know that. Those are some dual MOSFETs. So we took the MOSFET out. Let's check for short. And it's still short. Let's quickly take out the second one. Let's check for short. And it's not short anymore, okay? So that MOSFET is burned. Let's solder this MOSFET back. Oh, actually, let's solder this MOSFET instead of the burning one. And I'll tell you why. Because just fitting here a good MOSFET, yeah, we can see if it will work, so we know if it's a driver issue or a MOSFET issue. Yeah, so I prefer to solder on this spot where the MOSFET was burned to solder another MOSFET. Because if this MOSFET is getting burned also, that means it's a driver issue. Okay. Great. Good. Now, do we have this kind of MOSFETs? What MOSFET it is? Anyone knows? No one? Let's see. Three six 352. 36352. Let's see. 36352 MOSFET. £18 on eBay. Wow. N-channel MOSFET. $30 dual asymmetric N-channel MOSFET. Yeah, we have to order this one. Let me see what we have here. 1 second. I do have 1 second. No, it's different. Okay. No, you know what's the thing? We have to replace with exactly the same MOSFET. So indeed, I have like nearly the same MOSFET, but it's not the same. It's nearly the same. So we cannot play and. I mean, don't get me wrong. Probably it will work, but on some point they are in parallel mode. Yeah. The power supply. So if it's not working the same, the other one it will work harder and it will get burned sooner. Okay. Can this laptop work without? Possible. Not sure. But very possible. Let's test. I know it will work without the GPU one. Wait, what MOSFETs do we have? No, we have something else. Or not. Oh wait, 1 second. I will take one from the GPU. Just to see if the CPU is good. E6932. No, this is different. 6932, no, it's different. It's not the same. It's not the same. Six nine three two. 69. Yeah, that's better. E6932. And this one 36352. Okay, so it's not the same. Those are not the same, obviously. That's the first and the second MOSFET. Do we have any more power supplies here? Where can I find this MOSFET? What's that? Oh, that's a normal MOSFET. No, I think we have no chance. We have to order the MOSFET. Yeah, most likely. Let's try a short test. Maybe the laptop it will come on. Maybe the CPU is still good. Let's come with the power supply. Ground. 18 volts. And it's fine, it's not short. Let's see, you can power up. Where is the power button? It's on the keyboard. Power on, nothing. Oh wait, I think my ground sucks, or not. Power on, nothing. No, my probes are good. It's taking no current. Let me get the original charger, because I don't know why this charging port has so many pins. 1 second. Okay, let's plug the charger. So we plug the charger, and let's press the power on button. And I can't see any light. Okay, let's check the voltage. Let's see the voltage. So after the second MOSFET we have nothing. Good. On the input we have 19.5, you can see. On the output we have 0. So either this MOSFET is burned, but we can find out. Let's find out. How we can find out if a MOSFET is burned or not? First, see if it's a NPN, channel N or channel P MOSFET. And this is a channel N MOSFET. That means on the gate I should have positive. Yeah, so I should have 19. And I have 0. Okay, so the MOSFET is good, but I have nothing on gate. Okay, why do I have no voltage on gate? Anyone knows? No one? Let's check. Let's unplug the charger and check the second MOSFET. Let's see if it's shorted. No, the second MOSFET is not shorted, and obviously this not. Let me check with the power supply if the board is fine or it's still shorted. No, the board is not shorted. No, I came with the power supply and it's not shorted. So what's going on here? Let's come with the power supply here after the second MOSFET. And no, it's not shorted. So why is it not working then? Here, no, not short, no current, nothing. Because my 3.3 volts power supply is dead, or my Super IO is dead? Possible. Very possible and very, very probable. No, and we still have no voltage. That's bad. That means here is another issue. Not only this one. I mean one more issue. Let's have a look for the 3.3 volts power supply. Yeah? So we have a KB chip here. Here we have some power supplies. Okay, let me unplug the charger and let me find the 3.3 volts power supply. Okay, let me find the 3.3 volts power supply. How we can find it? How we can find the 3.3 volts power supply? Let's have a look on the I/O chip. Let's have a look for the capacitor or big power rails. And I can't really see. Maybe this one. 0 ohms. Oh, this is plus. No, it's not this one. Big power rails. Not the. Oh, you know. Oh, I remember. Oh, okay. You remember I have a video with a laptop like this with the screen connector blow up, and I have to put cut the cable and solder the wires exactly here. You remember that? Oh yeah, now I remember. Yeah, I had a video about this type of laptop. Yeah, I remember now. Okay, let's see. No, it's not the same track. It's not the same one. Let's see here. This one. No. Here. No. How can I find out which one it's 3.3 here? This one. Yeah, must be this one. No. Yeah, it's this one. Okay, so this pin and this pin are connected, and this one is connected to 3.3. This one and this one. Okay, and with the ground is not short. Now let's find the 3.3 volts power supply. That's how you find the 3.3. But where can I find the 3.3 volts power supply then? Yeah, I found it. I found it. Is the output This one, you can hear it's beeping and you can see 0 ohms. So the output of this one, yeah, this pin is 3.3. Found it. No, the coil probably is for different voltage, who knows? BA, BBZF. Never heard about this. Let's plug the charger and see the voltage on that chip. I plug the charger. Let's see, ground. And here nothing. Okay, the input. Let's see the input. Nothing. And nothing. Okay, that's weird. Here probably must be 5 volts. Not sure. Okay, that's weird. That here we should have 3.3, but we have no voltage on the input. Let's come with 3.3 volts. Let's see what is happening. .3. Nothing. It's no short. It's taking no current. Nothing. Okay, it's a dead end. So we can focus on the MOSFETs. Okay, let's focus on the MOSFETs. But how? Let's see the power management chip, yeah? Don't tell me it's on the other side of the board. Is this one, right? No. No, this is for CPU power supply. No, it's not that one. Probably it's on the other side of the board. What's that resistor? This looks weird. Why that resistor is desoldered? I have 19. It's moving, look. So I done nothing. Okay, let's solder that back. So someone, you see, that's what I'm trying to tell you. I try to tell you so many times. If someone is working before, yeah, and this is a happy case, this is a big resistor. But just think, yeah, okay, maybe it's a, I don't know, a random resistor here. Very possible you will never find that resistor. So when someone is working, you know, these things can happen. And that's why I'm trying to avoid working on laptops which they carry previous work. So you know what's happening here? What is this resistor? I'll tell you what is this resistor. So the main power rail, yeah, pay attention, is going here, yeah. Just ignore the resistor. The track is coming straight here, and from here, yeah, it's coming. Look at the track. It's coming here to the first MOSFET here. Now, from the input of the voltage, also we have this resistor, and you have here you have a capacitor, and here you have a track, yeah. So this is going to the power management chip, and very possible to that 3.3 volts power supply, which is for the Super I/O. Yeah. Okay. So now if I plug the thingy, the charger should work. Plug in the charger. Let's see if it's coming on. Power on. I can't see any light. Okay, let's check the voltages. Nah, the main power rail is not present. Nah, still dead. Still dead. But that resistor is doing the job. Something is getting hot. Lol, my CPU is getting hot. So the laptop just start. Let's put the heatsink back. No. Let me go in the power supply to be sure nothing is shorted. No, nothing is shorted. But how the CPU can get hot without power? Ah, no, the board got warm. 1 second, the board got warm because I soldered that resistor. And the laptop is still taking no power at all. Okay, let me check something. So where the voltage is going after that resistor? So that resistor, it is good. It's not coming here. No. It's going to the power management chip, which I don't know where it is. It's probably on the other side of the board. Yeah, we have to take the board out and check. But I really think here we are dealing with two different faults, and this fault, yeah, this one, which we are looking right now, I don't think have nothing to do with actually the main fault why this laptop died. This laptop died because of a shorted MOSFET. And after that something happened, and I can see the input power circuit is not working. So you see, that's I'm trying to explain you. We are working for nothing right now. I mean, we work and found the original fault, but now we are looking for a random fault caused by someone. That's what I think. Maybe I'm wrong. Let's see. If I'm wrong, I will apologize. I have no problem with apologizing. I'm happy the I/O chip is not shorted. That's a good sign. Lol, I plugged the BIOS battery cable and the pins comes out. Someone took the board out. Oh, I think the customer was saying those burn marks. Okay. Let's see. Those burn marks are from heat. There's a kind of normal on a gaming laptop. But my issue is the input circuit. So where is the power management chip? This one, yeah, BQ. This one. Yeah, let's plug the charger and check the voltage on this one. Let's plug the charger. Let's see what he doesn't like. He has the voltage. has nothing. He has nothing. Nothing. 20 volts. You see on the power supply? 20 volts, and on the output nothing. This must be a regulator, so one pin is to the ground. I don't know if you can see. I don't know if it's a regulator. Sorry, I'm just telling you what I think. Can be a regulator, can be a MOSFET. I think it's a regulator. That's my thingy, yeah? So here is ground. You can see the big ground track. Here is plus. This is clearly plus. You have a resistor, you have a capacitor. Clearly, this is a big power rail, yeah? And here you have 20. Yeah, you can see. So here you have 20. Here you have ground. What do you think we should have on the output? On the output we should have some voltage, but we have nothing. Or no, it's not. I can't feel it. Or the output is shorted. Yeah. Let's check that BQ chip. I'm trying to explain like a logical approach to this thingy. Now, what should be the output of that one? I have no idea what should be the output. Let's try 5 volts. That chip should be able to handle 5 volts. I'm pretty sure it's working with 20, but anyway. And it's taking no power, nothing, yeah? That means this thingy, whatever it is, and I have no idea what it is burnt. So what's that? What is that? S43, K4. What is that? S43 K4 chip. It's a chip or whatever it is. Nothing. But nothing. You know what? I don't need this thing. One second. Well, I don't even need it. No, I don't need it. S43. I don't know what it is. It's nothing. S43. Let's see. Regulator. Must be a regulator. Nothing on Google. Regulated chip. Must be a regulator. I found some. I don't know if it's this one. Is this one? No, this is something else. No. S4, one second. S43 voltage detector IC. One second, voltage detector. So this is creating the risk. No way. No way. That's a power rail. No, must be a regulator. No. No, you know what? No. We are wasting time. We are wasting time, yeah? We are wasting time. Let's check the BQ. BQ 24781. 24781. BQ. Yeah, let's see what the chip need. Seven, 8, 1. What is this? Okay. So the pin here, yeah, the pin here. Oh, we were wrong. No, okay, I take my words back. Sorry. I take my words back. Is this diode, this double diode. So actually what's happening here, I was thinking, yeah, just pay attention to understand where I was wrong. I was saying, okay, here we have 20 volts, here 19. Here we have ground because it's a big truck. No, it's a big truck of plus. Yeah, you can look here. This is plus. This is clearly plus. And where is going? It's going here. Yeah, this is a plus truck and I don't have voltage there. It's coming here. Yeah, so the truck is coming here. And it's taking voltage from the output of those two MOSFETs, okay? But one second, because something still doesn't make sense. Okay, so it's a voltage detector. That means must be two diodes on this way, so I should have here voltage if it's a diode on that way, right? Yeah, you see? Sorry, is not stupid. Told you it's faulty. I misunderstood this big truck. I was thinking, you know, that's ground. No, it's not. Are two diodes. Anyone can tell me why this is here? You know why? So this chip, it will know when it's working on the battery and with the charger plugged in. Remember, we have voltage on this pin. This pin we have voltage because the voltage comes before the first two MOSFETs, comes exactly from the plus of the charging port. So that means if I unplug the charger, the voltage here will be 0, and the voltage on this point, which is after the two MOSFETs, it's actually where the battery is bringing the voltage. Yeah? Yeah, that's the thing. So I can't short. These are two different points. Yeah, this is before the MOSFET, this is after the MOSFETs. Yeah, I cannot short them clearly, so I need two diodes from here to here and from here to here. But for our purposes, we can use like usual, a proper calibrated wire, yeah, or fuse. For our purpose, just to understand if it's good or not. Happy? Yeah. You know, let me tell you a story. The first shop what I had was a TV repair shop. And I was young, I was like 25, yeah? No, early. No, like 25, I think, yeah. And we have an hang on the wall, yeah? We have a piece of wire. No, we had that piece of wire for like 2-3 years. We made so much money with that piece of wire. We made like thousands just using that piece of wire, taking like a little bit soldering, making a fuse. Yeah. We made so much money with that piece of wire. It was insane. It was the most expensive item I had in that shop. I mean, we made so much money with that piece of wire, and particularly that piece of wire which we were using just to build the fuses or trucks or and he was hanging on the wall, you know, like in a proper important place. Yeah. Wait, let me cut down the extra wire. Yeah, I have nice memories. Okay, so now we should have a working laptop, right? Yeah. So if I plug the charger now, I should have voltage. Let's see, do we have our main power rail present? We do. We do have, yeah? So our main power rail is present. Now let's put the board back and see if this is working. We don't need BIOS battery. So the most used item proved to be a wire. Memories. You know, I wish I can go back in time and live one more time. I will change nothing. Nothing. I will change nothing. Well, maybe a few things. So. Yeah, that's, you know, that's called collateral damage, I believe. So what will happen now? We short that pin with the wire. What will happen? In the moment we are plugging now the charger, it will not work with the battery. Yeah, so it will charge the battery, but it will not work with the battery because the BQ chip doesn't have voltage. Yeah, so that's what will happen. And that diode is the same like on the MacBooks, so I have to buy a bunch of those double diodes, or we can use 2 diodes. I think it's more easy just to buy a double diode. I mean, don't buy 1, just buy 10. So you understand why many times, like even now, I didn't even bother to check if I have a schematic or not for this laptop. The first, it will keep your mind open, yeah, and it will keep your mind trained, yeah. Just have a look for the chip you are looking for, yeah, for the data sheet, like on our case, the BQ one, and try to figure it by yourself, the schematic. Yeah, it's better for your, you know, What's wrong with this battery? This battery doesn't have screws. Why the battery is not coming out? Okay, that's some clips. Okay, I got it. Good. You know, all I want to do, and I'm working right now just to see if the CPU is still good. I don't think it will start, but let's try. Okay, let's see if the laptop it will start actually. We can have a faulty Super IO, yeah we can. Let's see. No, the laptop is dead. Nothing. No, nothing. Good. So our main power rail is present. It is 19.5, you can see on the screen. It is present. Now the 3.3, which already we identified, it is present. It is 3.3, you can see on the screen, is present. So we have 3.3 now. Remember, we identify blindfold the 3.3 volts power rail. Here, that's the one, you can see. This is not getting hot, but still the laptop doesn't come on when I press the power button. Nah, it's not because of that diode. No. You know, it's curious. I don't understand how that diode died. It doesn't make sense. I mean, a fault must have like a sense, like a common sense. I mean, okay, I understand that diode can get burned, but what's the connection between that diode from that BQ chip and the MOSFET which is shortened on the CPU? This doesn't make sense, okay? Oh, sorry, 19. This is pretty weird. I mean, it's taking no current at all. But it's still okay. I have voltage, so I cannot complain. Yeah, I do have voltage. Okay, that's fine. Let's check the voltage for the power button, yeah? Let's follow the normal, route to the... You think that BQ chip can be burned? And he's not speaking with the... Can be. Can be. So I do have few pins. Oh, that's for charging. Okay, that's right. That's the data from the battery. Okay. AC detect. DC in. And that safety protect, it will switch down the this voltage. Okay. AC detect, yeah. I mean, why we found this diode bad? No, this diode was bad. No, sorry, this schematic is wrong. 1 second. No, this is wrong. You see, I think someone drew this schematic. So this schematic doesn't make sense, yeah? So it doesn't make sense to have two diodes, okay? Doesn't make sense to have two diodes on the parallel mode on this configuration. No way. So one diode is connected here, and one diode, like on our circuit, is connected exactly here. You see, this schematic is wrong. Okay. Okay, do we have 3.3? We must have. We have no voltage on the keyboard. How this is possible? The power button, it is on the keyboard, right? Yeah, it's on the keyboard. It's here. Why we have no voltage on the keyboard? Anyone can tell me? Come on, guys. You know what? I should do like a live stream with it with repairs. So you can help me, guys. Actually, let's leave the charger in. Let's unplug the keyboard. The keyboard can be faulty, yeah, it can be. Let's try one more time without the keyboard. 3.2. I mean, the voltage pop up like instantly after I disconnect the keyboard. 3.2. That one is the power on? Yeah, that one. Yeah, this one, the first one, 3.2. And if I plug the keyboard in, I do have 3.2. What? By test. 1 second, let me press the power button. Pressing the power button, going to 0, you can see. And the laptop comes on. Wait, I don't have heatsink. Wait. And the laptop comes on. Let's put the heatsink. Let's put the heatsink. That's good. That means our Super I chip it's alive, and that's a good thing. That's a very good thing. So we have the heatsink. But that's good. No one noticed our MOSFET, which when we move it here, we move one MOSFET, didn't blow up. That means the driver of the MOSFET is good. So I can order that MOSFET. Yeah. No one noticed that. Because if the driver was dead, was faulty, not dead, sorry, it will blow up the MOSFET, that MOSFET instantly. No one noticed that, right? Good. Now let's test. Let's see. We don't have BIOS battery, but we don't need it. And the laptop comes on. I can see it on. I can see the lights. It will work without that MOSFET or not. Let's wait, because we reset the BIOS. No. So we don't know if if the CPU is good or not. Wait, the laptop shut down, and it will start. No. Power on. The laptop is coming on. So actually we don't know if the CPU is good or not. And it's shutting down after a while. That can be because of that MOSFET, that missing MOSFET. But I want to know if the CPU is good or not. Well, I believe we have to order the MOSFET and see if it's working, and you know, in this moment there's nothing what I can do. I mean, we bring the laptop to life. I mean, it's coming on. But what can I do more? That double diode is not a problem just for testing. We have to order the diode also. And we have to order a MOSFET. But let me check, is the primary V-core or which one it is? That one, must be, yeah? One second. So those are together, yeah? One second. Yeah, they are together. Together with this. We have 1.2. We have 1.2 ohms with the ground. 1.2 ohms with the ground. 1.2. 1.2. 1.2. And 4.5. You know what? I just want to know if I should order, because if the CPU is that I'm ordered parts from my pocket and I can't take the money out. Let me check something. Yeah, just 1 second. Let me check. 1 second. We have to be sure if the CPU is good or not. Yeah, let me check this one. Yeah, it's not the same. It's not the same. No, it's not the same. What a shame. So we have one pin there, one pin there. 1 second, 1 second. One pin there. Oh lol, it's not the same, but it will work. Yeah. Let me remove a MOSFET. It'll do the job. Okay. 1 second. Oh, no, it's okay. It's okay. It's okay. It's okay. It's okay. It's okay. It's not the same. It's not the same. But it'll do the job. 1 second. 1 second. 1 second. I mean, what? We cannot blow up a MOSFET? Of course we can. That would be nice. Sparks. It would be like a little Chernobyl here. 1 second. Well, let's use some flux. Huh? What do you think? Wow. Wow, this is hot. This is hot. Short on the motherboard, let's see. No, nothing. The motherboard is still hot. Okay, let's test. Power on. The laptop is on. Nothing blow up? Not yet. Why I have no picture? Yeah, I should check the voltages, but how can I check with the heatsink on? Let me see if it's shutting down. Wow, the chipset is mad hot. That's normal. You know what? It's not shutting down. But we have no picture at all. Okay, the CEO chip is responding to the long press of the power button. Can be the RAM memory? So the CEO chip looks like it's working fine. I think we have a dead CPU here. That's what I think. I mean, 1.2 ohms is kind of low. I will expect probably like 4 ohms, 5 ohms. Maybe I'm wrong. Maybe I'm wrong. Okay, so it's no picture whatsoever. Let's check with the other RAM memory, just to be sure, you know, we don't have a RAM memory issue. But the RAM memory has voltage. I haven't checked. Let's check. So the RAM memory has 2.5, so it is, the voltage is right on the RAM memory. But we have no picture on the screen. Okay, let's shut down the computer. It's warm, so clearly the voltage is present. Yeah, clearly the voltage is present. Let's see. Let's try somehow to do it quickly. Yeah? So this is the multimeter, ground. Plus, let's see, power on. Here you have nothing. Here you have nothing. 0 and 0. What? Yeah, it shut down because we don't have heatsink on. But what's wrong here? Wait. So here we do have 0.9. You can see, check on the screen, 0.9, 0.9, and here nothing. Probably that's the boost one. We have 0.9 on the CPU and it's not coming on. We have no picture. You know, let's check the CPU. If the CPU is getting hot, uniform, I think we can. I don't know. I don't even think it's point to order a MOSFET. Probably not. I mean, I'm pretty sure this should work even without that MOSFET, and it's not. It's not working. Let's get the power supply 0.9, yeah. 0.9 minus, and it's taking decent amount of current. No, sorry, I'm on the limit. I'm on the limit. It's taking 2.5 amps. I think it's too much. 2.5 amps. Or maybe not. It is too much. 2.5. Doing nothing. Okay, so that's the CPU. Yeah, you can't see it. That's the CPU. Okay, so power on. One second. Let me concentrate on this and I'll show you after. Oh, it's getting hot in one corner. No, sorry. One side of the CPU. So power on, off. I don't know, it's kind of weird. You know what, I think I'll stop with this video because I can order, I can give this laptop a chance and order that MOSFET. Pointless. It's a pointless thing, but that's all what I can do. It's nothing else what I can do. But leave me a comment. What you will do in this case? You will go further and order the MOSFET or not? I'm just curious your opinion. Don't get me wrong. So are 4 MOSFETs and 4 coils, yeah, only for this V core. So yeah, one was burned, okay, but you still have 3 phases left. If the MOSFET doesn't have any feedback, possible to have, because after we feed the MOSFET, the computer is not rebooting itself, yeah, so it's staying on. Not sure what I can say. You know what? I'm confused. I will upload the video and I'm waiting to see your opinion. You know, my opinion is that this processor is dead. That's my opinion, but maybe you have a different opinion. Maybe you know some magic. You know some magic? And the chipset is getting mad hot. I mean, I can order that MOSFET, that's not a problem. We had a double diode, we can order that one. So what do you think? We should order that MOSFET? I mean, it's against our experience. It's against that to order that MOSFET. I mean, we have the voltage, and for me that's enough. You know, that's the point. Okay, we have the voltage. Yeah, the CPU is we have no picture. Yeah, then the CPU or the chipset is dead. I believe this has switching graphics, right? So when you start, it's working on the chipset. I was so close to fix it, so close. Okay, so leave a comment and tell me we should replace that MOSFET or not. So I will say thank you for watching. Like and subscribe if you like the video, like always. I don't know why you like this video. We didn't fix it. But at least, you know what? No, at least, you know what? This is a lot to learn on this video, how to diagnose, you know, the steps to diagnose the motherboard. Yeah. Yeah, so you see, we start from nothing, from scratch. And we go to the main power rail, we took the short out, then we have no power, yeah? We go straight to the CO chip, then from the CO chip we go to the 3.3 volts power supply, then from there we go to the power management chip, to the BQ chip, and there we found out actually that chip has no voltage. Yeah, you remember, that's how we, yeah. Okay, so see you next time, bye.